We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
Hi, I'm Michael Policelli, and I'm the Chief Technologist for the team and also the Propulsion Lead. Something we've been working on is preparing for our rocket engine tests, and I've been working on, in coordination with university faculty and also researchers at the Applied Research Lab and at NASA Johnson folks, is developing our propellant feed system, and that will allow us to bring liquid oxygen and our fuel up to the required pressures in order to feed the rocket engine in order to successfully execute a hot fire. And so this is a version of our schematic, and this has gone through many iterations over the past few months, but now we finally got to a point where we're confident in moving forward. One of the things though that we've gone through is the exercise of saying, all right, here's our liquid oxygen, and this is the path it's going to be taking while we're executing a test. And this has to be a fail close, and this has to be a fail close, this has to be a fail open in order to have the required fluid path flow in for a normal operation, but then also for any event of emergency or for proper shutdown. Then it's a whole other thing to say, okay, now I understand all these two-dimensional lines to, I have this cryogenic hand valve that goes right here, and I have this T-fitting that goes right there, and then how am I connecting these? How are these being arranged in three-dimensional space? And the nice thing about these, the connects, is that the actual size of the components is pretty much real size. So when we build our real propellant delivery system, it's going to be very close to this size. For example, this is a fail closed solenoid, and that's represented by this piece right here. So, and then this T-fitting is going to be right there. So this is the same type of the high fidelity that we can get with a model like this. One of the reasons that this was really instrumental to do is that all this plumbing structure can't just hang by itself. It has to be supported by some sort of structure. So we have to have, some way to tie this to a steel frame so the components aren't just hanging off of each other. The next phase of the project is digital, and we need to draw up our plumbing system in a program that does 3D drafting. So for example, this right here is our fail close solenoid, and then this is the fitting that allows us to connect this to this T-fitting. Okay, and so these three things connect, and that's represented right here on this drawing. The purpose of this is that now that we've gone from our plumbing schematic on paper, then we've gone to the plastic version and connects, and now we have the digital version. This version will allow us to design the structure that we attach the plumbing system to. And now you've seen a little bit of the process by which a team of students taught themselves how to go from the rocket equation to firing a rocket. We've gone from paper, we've gone to plastic, we're going to digital, and next we're going to begin the physical construction. And it's been a really exciting ride, and we've learned a lot over this past summer, and the next stop is the moon.